Okay, good morning for this today's section. So the unit name is Open Channel Flow. So here we have few things discussion on the flow in a open channel flow. The first topic is regarding differentiate between the open channel flow and the pipe flow. So this is the first introduction topic on open channel. And about the pipe flow, we have known the difference between the pipe flow. Before that, going to see about the open channel flow and pipe flow. So after that, definition and explanation based on the types of flow, then state of flow, then flow rhythms, then channel geometrics. So these are the things has been discussed in this slides. Okay. So the next slide, we move into the open channel. So what is the pipe flow? So first we have to initiate with the pipe flow. So the pipe flow, which means that the water will go in a passage or in a closed conduct with some of the with the help of some of the pump, anything with the fluid can transport from one place to another place. So that is called the pipe flow. What is the what's the open flow? So the definition for the open flow, it means that it does not have any closed conduct. So it's open to the atmosphere. It means that the top layer of the channel will be always open. That is called as open channel. When the flow entire circuit get closed, then it is called as a closed conduct, and that is the pipe flow. Okay, this is a major difference between these two things. An example for the open channel flow is a river, a river and stream. The flow in a irrigation canal. We can say it is a canal or a channel. So both the things has been same. Then drainage channel and sewer, the navigation channel. So for the purpose of navigation, we are using open channel only. So these are all the example for the open channel flow. Then we have the few characteristics of channel flow. So first one is pressure constant along the water surface. Then gravity drives the motion. The pressure is approximately hydrostatic. The flow is turbulent and unaffected by the surface tension. It means that the pressure in the open channel flow will be the same along over through the travel path where the travel, there is no changes in the pressure. The pressure always remains a constant in the open channel flow. So if any obstruction, the some may get vary. So there is a chance will be the less number for the pressure variation in a open channel flow. This all in this channel, the water flows only through the gravity. So that's a called a free flow. There is no external pumping station or either some external forces has been given to the fluid to move from the transportation of one place to another place. So itself having, there is a gravity flow, there is no gradient. So the water will be the free flow. So that's a thing has been given in this drawing. In an open channel flow is a flow of liquid in a conduct. It means that uh, it does not have a conduct. It's free, it's a free surface. So it flows as a free surface and subjected to the atmosphere. It means that it is subjected to the atmosphere means it's open to the top layer. Okay. So that's a these are the example has been given for this open channel flow. The flow of water in rivers, then canal, then partially sewers, then drains, then flow water over the land. So these are all the example for this open channel flow. Then practical application where we have to find out the determination of this open channel flow. The flow depth in river, canal and other convenience conduct changes in the flow depth due to the channel control. Example, weir, swellway, gate. So these are all the example for the open channel flow. Changes in river stage during the flooding, then surface runoff from rainfall overland, then optimal channel design and others. So these are the practical observation determination of the open channel flow. Okay, so this is the flow characteristics and geometric elements for the open channel flow. So from the aspect of the difference between the open channel flow and the pipe flow, so the free surface, in the aspect of free surface, open channel have the free surface and pipe flow have no free surface. As the cause of flow, in the aspect the cause of flow, the open channel will be the gravity flow. Pipe flow is always in a hydraulic forces. The geometry of the open channel flow is in a triangular way, or in a rectangular, or in a trapezoidal, or a parabolic, or a circular. So it's maybe in a any shape. Okay. So then in a pipe flow, it's a round in cross section. It's a round in a cross section. It means that it's a pipe flow. It's a closed conductor. So always in a circular. Okay, that's only way I said that it's in a cross section way. The stream is in an open channel flow. The stream is unconfined, can expand or contract. Places may contract or expansion will happen in a open channel flow. In a pipe flow, we could not have that make as changes. May possible. Uh, may possible means it will goes to the minor loss. So there must be a sum of the obstruction or any point of water will be slowed down. So that will leads to the minor loss. Then surface roughness. So hydraulic roughness varies with the depth of flow in an open channel flow. In a pipe flow, roughness coefficient varies depending upon the material of the pipe. Okay, so these are the things have been differentiation between these. Then flow parameters and geometric elements are depth of flow. We calculated with depth of flow. We take it as a y. This is a vertical measure of the water depth. Normal depth has been calculated as that small d. So it's a measure of normal to the channel bottom. Then the equation will be taken as d equal to y into cos theta. So the theta value may be the less than or equal to 10 degree. It should not have the more deflection or deviation in the bottom slope. When a bottom slope will get exceed, the water cannot flow freely. So at the time there must be a external pumping station or anything has been given to the water. It's not possible in a open channel always. When it is a pipe flow, we can give a pumping station here. In an open channel, it not taken to an account. Okay, flow or discharge, which is calculated as a Q, is the volume of fluid passing a cross section perpendicular to the direction of flow per unit time. Here, the mean velocity V is the discharge divided by the cross-sectional area V equal to Q divided by A. So generally, the general equation for finding the discharge equal to Q equal to A into V. So this is the equation have been find out for the discharge. Okay. So here the variation has been given that V equal to Q divided by A. Then next, this is the geometric element, wetted perimeter. So wetted perimeter for the trapezoidal section and wetted perimeter for the rectangular section. Then everything has been filled. So wetted perimeter, it means that we have the two side. When it is slope, we have to consider with the slope. Otherwise, two sides plus top width. So that is a point has been considerable. So that is a here it's a that diagram which represent the trapezoidal channel, which always having the top width and bottom which will have the different. It have the side slope that is calculated as m. So it means that the horizontal the slope between the horizontal and vertical ratio. So this is the wetted perimeter. Then hydraulic mean radius. Hydraulic mean radius is the ratio of the flow area to the wetted perimeter R equal to A divided by P. Then hydraulic depth D is the average depth of the regular cross section, that is D equal to A divided by D. So here it is the top width, then bottom width is taken as a B, then perimeter is taken as a P, then Y is the depth of the water. So these are the geometrical calculation, geometrical elements required for finding the hydraulic depth, hydraulic radius, those all the things. Okay, so this is the types of channel geometrics. It's a this is for the uh, rectangular channel, triangular channel, trapezoidal channel, and circular channel. So these are all the open channel geometrics. So in an area we calculated and are finded as area equal to b into y. So this is for the rectangular channel. When top width is taken as capital B, then perimeter will be calculated as B plus 2y. It means that B plus 2y, where it comes from B plus 2y. Breadth plus depth of the two sides are adding, that is 2y plus breadth. So that is the perimeter for the rectangular channel. So majorly the channel will available in a rectangle or either in a trapezoidal channel. So there are a few more possibilities for circular channel. Is the possibility will be the low. So this is the formulas for finding the area, then top width, and then perimeter of the channel. Then types of open channel. Type of open channel are the prismatic and non-prismatic channel. The prismatic channel is the channel which the cross section, shape and size, bottom slope are the constant. Most of the man-made structure or artificial structures are the prismatic channel over the long stretches. Example of man-made channels or canal, irrigation canal film. That is the hydraulic film is nothing but it's also one type of the open channel. Then drainage and ditches, then roadside gutters, drop chutes, culvert, tunnels. So these are all comes under the category of the prismatic channel. Prismatic channel means it have the regular cross-sectional area, shape, and bottom slope. When it is compared with the non-prismatic, it means that it does not have the way, it having the varying cross-section at a particular point. At a point to point, the cross-section will be that gets before in a non-prismatic channel. Non-prismatic channel having the varying cross-sectional and therefore are non-prismatic. Example for natural channels are tiny, hilly rivulet through brooks, then streams, rivers. So those area having the non-prismatic channels. Then rigid and the boundary channel boundary. Rigid channel are the channel with the boundary that it is not deformable. Channel geometry and roughness or the constant over the time. The typically example are lined canal and sewer and non-erodible unlined canals. Mobile boundary channels are the channel with the boundary that is undergo the deformation due to the continuous process of erosion and deposition due to the flow. Examples are unlined man-made channels and rivers. The next thing is these are the example. In a laboratory setup, we have the open film in the laboratory. It also it will comes into the practical application to the student. So film is an how it's naturally available. Film is a channel wood, metal, concrete, or a masonry usually supported on supported above the surface of the ground to carry the water across the depression. So this is the film. In laboratory setup, film has been used. It have the adjustable bottom slope, then to find the critical depth, normal depth, then some obstruction has been laid down, then critical flow, subcritical flow, then critical flow has been developed in the by using this open channel in a hydraulic film. Then this is the chute. Then this one is the drop, water drawn from the weir. Okay, stormwater sewer. Then we move into the types and classification of the open channel flow. In an open channel flow, we have converted into uniform flow, non-uniform flow, steady flow, and unsteady flow. So these are the classification based on this time, area. Those all comes into the category. Uniform flow, constant water depth. Depth changes in a non-uniform flow. Then time is not and change in a steady flow. The time gets changes in a unsteady flow. So open channel generally classified into two types. One is steady flow and another is unsteady flow. Then these unsteady and steady flow are combined to get an uniform flow and non-uniform flow. Again, the non-uniform flow the variation into rapidly varied flow and gradually varied flows. Okay, so gradually varied flow, this does not happen in a sudden. When over the water flowing over the long distance, the gradually varied flow will occur. Rapidly varied flow will occur in a short distance. So then state and how the flow can be whereas classified as based on the Reynolds number. So based on this Reynolds number, then based on the Froude number. Based on the Froude number, we can classify the flow, that is regions of flow, subcritical laminar, supercritical laminar, subcritical turbulent, and subcritical turbulent. So that's all. And thank you for the session. Thank you.